All right, we're going to move on to B. Any questions with A?
Sir,
Yeah,
so
either.
what would the point of intersection be?
The point of intersection would be 1, -5. It's not asking you for that though, but yeah, that would be the point of intersection. All right, Daniel, I know you haven't seen it yet, but I'm going to take your phone, okay? That's part of my classroom rules. I'm going to take this phone as well. If you, I can help you out with those rules after the lesson today. B. Here, we already have y set up for us. Nice, so we can just substitute in the value for y here. Okay, so we're going to get 2x plus 3x plus 5 plus 10 equals 0. Any questions what I did there? I just took the value of y and I subbed it in. Now I'm going to solve for x. So I get 5x plus 5 plus 10 equals 0. So we get 5x plus 15 equals 0. 5x equals negative 15. X equals negative 3. Any questions? Okay, we're going to move right along to C. Here now we have two equations. I'm going to isolate x this time because I think it's easier, right? Because it's by itself. So I'm going to isolate x. I'm choosing to isolate x. I'm just going to say x is equal to negative 6, and I'm moving the y, the 2y over negative 2y. Any questions there? What I did?
Sir,
Yep.
you're allowed to have a negative y.
Yep, you're allowed to have that. Now I have x. I'm going to sub that x value in for x over here. So we're going to have 2 okay. Now we need to multiply these two terms. Okay. Now the 12 is going to come to the other side. The negative 4y and plus 5y is just going to give me y. So we got y is equal to negative 6. Notice how I always put a box around my final answer? You guys should be doing the same thing on tests, okay? Written tests, you're going to circle your final answer. What do I do with this value now? Y equals negative 6. Jaden. Yeah, which one should I plug it into? The one at the top? The bottom? Does it matter? Doesn't matter. Why the top one? Yeah, it's easier, right? I would pick the top one. Doesn't matter, but I would pick the top one. So then we have x plus 2 negative 6 equals negative 6. So we have x minus 12 equals negative 6. X equals negative 6 plus 12 equals 6. Any questions there? Now what do? I have x and negative 6. Daniel, you know what to do? Yeah, you're Daniel, right? What do? We did it over here. Actually, I didn't do it down here, did I? Oh, I got interrupted on B. I never finished this question. We'll go back there. What do I do when I have these two values? Do you remember, Daniel? No? No idea? Douglas, what do?
You substitute it.
Yeah, I substituted it. Which formula?
The bottom.
Does it matter? Doesn't matter, no. So you could do either one. Let's do the bottom, sure. So I'm going to substitute this value for y and this value for x into this formula up here. Okay? So we have 2 times x is 6 plus 5 and y is negative 6 equals negative 18. So we have 12 minus 30 equals negative 18. Negative 18 equals negative 18. That is correct. Okay, I did not finish this one off. I got interrupted. We had x equals negative 3. So we're going to substitute that one back into the top value. So I have y equals 3, negative 3 plus 5 equals negative 9 plus 5 equals negative 4. So there's my two values of x and y. I can then sub them. Let's choose the bottom equation. 2 times negative 3 plus negative 4 plus 10 equals 0. Negative 6 minus 4 plus 10 equals 0. Negative 10 minus plus 10 equals 0. 0 equals 0. Any questions? Yeah, Casey.
On C, at the top, when we move the negative 6 to the other side, wouldn't it have been positive? Top.
Where?
Wouldn't it be positive because we moved it to the other side of the equals?
This negative 6? I didn't move it. It was always on the right side. This one you're talking about?
Yeah.
I didn't move it. You moved the 2y. See the 2y jumped over the equals, but the negative 6 stayed on the right side. Do you see?
Yeah.
Good question. Any other questions? Yep.
Everything that we did, this is called substitution.
Yeah. Good question. It's called the method of substitution. Okay? And this is an alternative to finding where the lines intersect. Because what's it called when the lines intersect? What is that called? Sorry, it's called the point of intersection, or remember there was a fancy way of saying it? Yep. The solution, yes. It was called the solution to the system of equations. Very fancy way of saying point of intersection. All right. Let's go. We're making good time here. You're going to have some time. I'm hopeful. Example 2. Find the solution to the linear system using the substitution method. There it is again. The solution to the linear system. That's a fancy way of saying the point of intersection. Okay. C. What am I going to do here? RC, what's the first step?
Substitute any
You're right. The first point would be substitution. It was here. It was here. It wasn't here. The first point wasn't substitution. The problem with substitution as the first step is what? What's the problem with that, RC, with these two equations? What's
it's not isolated.
right. So the first step is not substitution, it's what?
Isolated.
Yeah, isolating. Good. Which one do you want to isolate? Top? Okay, we can. I would pick the bottom, just because I already see x by itself. You see it? Okay, can you isolate the x, RC?
2i equals.
No, let's start with x because it's already there. X, then what? What am I going to write? Rudy, can you help him? X equals, yeah, good. Positive 2y, yeah? Yes, nice. Nice, Rudy. Well done. Okay. Josiah, can you hear me?
Yeah.
Can you tell me the next step? Sorry? Remember the next step? We have x by itself. RC told us to isolate x. Now what? What? We want to get y, you're right, but how? What do we do?
X minus 2y plus 3 equals 0, then
No, I don't want you to actually, just tell me what to do. What's the next step?
I don't know.
You don't know? Okay, you gotta listen, okay? Pay attention, because it's always the same, Andrew.
Do we bring the x up to the top where minus 3x, 3x minus 6?
Yes,
Y is?
you're gonna sub this x in here. Now, does it matter which equation we sub it into? What do you think? What do you think, Max? Here, let's try it out. Let's see. Let's say it didn't matter. We're gonna substitute in here, right? Doesn't matter. So I'm gonna get 2y minus 3. I'm subbing that in for x. Minus 2y plus 3 equals 0. What do I end up with? I just get 0 equals 0. That didn't help. It does matter. I know it's getting confusing. When does it matter? When doesn't it matter? It matters at the beginning when you're substituting one equation into the other. It does matter. You have to sub. Because we used this equation to find x, we need to sub that equation into the other equation. Right? If it didn't matter, and we just took this y value and subbed it in for y, we would just get 3x minus 8 equals 3x minus 8. It matters when you first substitute.
So it matters when you have to isolate first?
Yes, it matters when you isolate for one variable, you need to sub that into the other variable. When it doesn't matter is when you're checking the answer. We're finding one variable from the other. Then it doesn't matter. But at the beginning, when you're substituting one equation into the other, of course it matters. Because, I mean, you could do it, but you're just going to get, like, look, if we use this y and we sub it in for this y, we'll get 3x minus 8 equals 3x minus 8. So it does matter at the beginning, right? It matters. We have to sub into this equation, the top equation. So then what do I get? I get 3 times x, which is that value, minus 6y equals 5. Okay, now I'm going to have 6y minus 9 minus 6y equals 5. So I get, looks like 0y, that's not right. It's not looking good. Let's see. This looks like I'm going to get 0y equals 14. Y equals 14 divided by 0, which is undefined. So what does that mean? Our y value is undefined. Was that possible? Let's see if I did this right. X 2y minus 3. Yep, that's right. 2y minus 3 minus 6y. 6y. Yeah, I did it right. So what's that mean? If y is undefined, x is undefined. Because if I substitute y in for y in either of these, I'm going to get undefined. Yeah, so what do you think that means about these two lines then? Yeah, Max.
It doesn't intersect.
Sorry?
It doesn't intersect.
Right, it doesn't intercept. They don't cross. There's no solution. So what does that mean about the lines?
They're like,
Sorry? They could be. I don't think they are. I don't think they're horizontal.
they're parallel.
They're parallel, yeah. So if their two lines are parallel, they won't intersect. Let's go ahead and check if they're parallel. How can we check if they're parallel without graphing them?
See if they have the same slope.
Good idea. How do we see if they have the same slope? Alan, how do we check if two lines have the same slope? Nope. That'll tell me where if they intersect. How do I check if they have the same slope?
You have to like come in m equals y to like the formula for slope.
Yeah, you'd do that if you had a point on the line, but we don't have points on the line. How can I check if they have the same slope? Zai, you remember? KG, you remember the equation of a line?
Like y equals mx.
Right. So if we can rewrite these as y equal mx plus b, Milkias, what will be the slope? Liam, if we know y equals mx plus b, what's the slope? 3. No. Y equals mx plus b. RC. Don't kick him. What's the slope? What's the slope in the equation of a line? Y equals mx plus b. Somebody, please. Anybody, put up your hand. Yes, Adrian. What? M. Yes. So if we can arrange these lines to y equals mx plus b, we can look at the value of m and see if it's the same. Agreed? You guys agree?
Sure.
All right, so let's try that, okay? So we're going to rearrange the first one to equal y equals mx plus b. So I have 3x minus 6y equals 5. Now, I don't know if anyone has actually gone over and practiced this at home, but as I said before, you need to have this skill, otherwise we can't do any of this stuff, right? So I'm going to leave the 6y on its own, 5 plus 3x on the other side. Now I'm going to have y equals 3 divided by negative 6, x plus 5 divided by negative 6. Yes, it's minus. Minus. So we get y equals 1/2 x minus 5 over 6. There is our first y equals mx plus b. Now I'm going to do the second one, x minus 2y plus 3 equals 0. We have negative 2y on this side equals negative x minus 3. Then we have y equals negative x divided by negative 2 minus 3 divided by minus 2. Everyone understand this? I hope. This is grade 9. We're solving, we're moving things around. We have y equals 1/2 x plus 3 over 2. Are these lines parallel, Josiah? Yes. Yeah. Okay. We know a little bit. Lucas, what do the lines look like? Do we know how they look? Do they look like this? Do they look like this? Lucas? Yeah, it's positive. So which way does it go? This one, right? Yeah. And is it like really steep or is it like really like... Sorry? Yeah. Because it's only a half, right? Any questions? So the two lines are parallel. That's why we got y is undefined. Make sense?
Yeah.
All right, let's keep going. B. What's the first step here? Jafet, what's the first step?
Isolate.
Yes, isolate. Which one should I isolate?
The first one.
Yep, and which letter? X or Y?
Y. Sorry.
Y. Okay, so we get y equals minus 4x plus 2. Do you agree?
Yes.
Right? Okay. Now I'm going to do what, Josiah, with the y? What am I going to do?
After that one, you go to the second one.
Say it louder?
Can I just tell you what to write?
No, I want you to tell me what to do with this. What's the next step?
Move on to the next one.
Move it into the next one, right? I'm going to substitute it in for y over here, right?
Yeah.
Okay, you tell me. Go ahead.
6 times 4x plus 1.5y equals 4.
Am I going to write y?
No, you don't have to.
What should I write? Sorry?
You can just leave it, right?
No, I have to substitute this y in, so I have to put this value in for y, right? You understand what we're doing?
Yeah.
We're taking this minus 4x plus 2. That's what I have to write here, right?
And then equals our 2.
Yeah, good. Okay, you want to keep going?
Well, after that, I think get
You want someone else to take over from here?
wait, can I just tell you what I got? Because after that, I got x.
No, that's not going to be helpful for us. We have to go through step by step, Josiah. So what's the next step? What do I write next? Stefan, do you know what to write next? Okay, Stefan, Max is going to help you. Go ahead, Max.
Solve the equation.
Okay, go ahead.
So, 6x
Yep.
plus 1.
It's going to be minus, right? Because we have 1.5 and a negative and a positive. So it's going to be minus what? What's 1.5 times 4?
6.
Max?
6.
Good. So 6 what?
X.
Okay? And then what?
Plus 3.
Good. Equals? Okay. So we end up getting 0x equals 0. X equals 0. Yay, another weird one for us. Our x value is 0. Okay, if we have x equals 0, we can substitute that in to the next equation. We will get 6 times 0 plus 1.5 y equals 3. So we get 1.5 y equals 3 because that's 0. We get y is equal to 2. So y is 2 and x is 0. So we can now verify if this point works. Let's just do it in our head here. Substitute in 0 for x, we get 0. Substitute in 2 for y, we get 2 minus 2. 0 equals 0. That one works. Substitute 0 for x, we get 0 here. Substitute 2 for 1.5, we get, or sorry, for y, we get 1.5 times 2. 3 equals 3. So the answer is 0, 2. Okay? Example 3. The following 3 lines intersect to form a triangle. Find the coordinates of each vertex. Who can tell me what a vertex is?
The point of the triangle.
Sorry?
The point of the triangle.
Yeah, the point of the triangle. So it says the 3 lines intersect to form a triangle. So they're going to go like this, right? There's 1 line, 2 lines, 3 lines. So basically what they're asking us for is what? What are they asking us for? RC?
The points of intersection.
Right, the points of intersection between this, this, and this. So what we need to do is first find the point of intersection between 1 and 2, the point of intersection between 1 and 3, the point of intersection between 2 and 3. Does that make sense?
Yeah.
We're finding 3 points of intersection. It gave us 3 formulas. Kind of confusing. We only need 2 formulas to find the point of intersection. We need to first find it between these 2, then find it between these 2, and then find it between these 2. Okay, so it's kind of like 3 problems in 1 here. All right, so let's do this. The first one, we're going to substitute y into the second one. Okay, so we're going to have, here's the second one, 3x plus, not y, but I'm going to use 2x because that's my value of y in the first one. Okay, equals 5. So we get 5x is equal to 5, x is equal to 1. All right? Now that I have x is equal to 1, I can sub that in to either equation. It doesn't matter in this case. I'm going to sub it in here, and I get y is equal to 2 times 1. Y is equal to 2. So the point of intersection between 1 and 2 is, let's do this, point of intersection, and I'll say 1, 2 is equal to 1, 2. Okay? Any questions? All right, next I'm going to do 1 and 3. Okay, so I'm going to take my y and substitute in for y over here. So I'm going to have x plus 2 times 2x equals negative 5. X plus 4x equals negative 5. 5x equals negative 5. X is equal to negative 1. Okay, now I can sub that back into my first equation again over here. And I get y is equal to 2 times negative 1 is equal to negative 2. Alright, so my point of intersection between 1 and 3 is equal to negative 1, negative 2. Any questions? Last one. I need to do the point of intersection between 2 and 3 now. Okay, so I'm going to isolate y here because it's by itself. So I'm going to come down here and say y is equal to 5 minus 3x. Right? I just moved the 3x over to the other side. Now I'm going to take that y and I'm going to sub it into my third equation here, right here. So I get x plus 2 times 5 minus 3x is equal to negative 5. Now we have x plus 10 minus 6. Somebody talking right now. Not sure why. Is there a question? No? Okay, we get minus 5x equals negative 15. X is equal to 3. Sub that one back into this equation. We get 3 times 3 plus y equals 5. 9 plus y equals 5. Y equals negative 4. So my point of intersection between 2 and 3 is equal to 3 and negative 4. Those are the points of the vertex of the triangle. Any questions? All right. Number 4, last one. Anna has 5 more fish in her aquarium than Brett has. Ooh, word problems. We love word problems. The two have a total of 31 fish. How many fish does Anna have? How many fish does Brett have? Okay, now you could probably figure this out just like using common sense, but it's probably not the way that the creator of this question intended you to figure it out, right? So, how do you think he wants us to figure this out, Max?
You do like equal variables with Anna and Brett.
Yes.
So like Anna's A and Brett is B.
Nice. Okay, so we're going to say Anna's fish are represented by A and Brett's fish are represented by B. Good, I like that.
We know that A plus 5 is like, or like B plus 5 equals, but like Anna has 5 more fish than Brett does, and it equals 31.
No, you were onto it at the beginning. You can do it from this. You had it.
So like
You were very close.
A plus 5,
Okay?
I think, and then it would be like,
So let's say A plus 5 equals, whoops, A plus 5 equals B. Is that what you're
No.
trying to say? No? Okay, what? You're very close, but it's a little bit the other way around. Chenier?
Would you put like plus 5 and then A inside of bracket so that it goes to the A and then you put equal and then you would put B and then equal 31?
Like that?
Yeah.
Nope. That's a hella confusing. That's a hell of a lot of confusion there. Not that? Okay, yeah, Adrian.
Is it like A equals B plus 5?
A equals B plus 5. So this is very similar to what Max said. Why is this right? Teodi, what's going on with that? Do you understand that equation?
Would you have to just put B plus 5 equal A? Would you put B plus 5 equals A?
Okay, yeah. You could do either. Yeah, they're the same thing. They're the same thing. All right, let me ask you guys a question. Why is it this, okay, and not this? Okay, we know. Liam, yeah. Yes, because Anna has 5 more, you have to add the 5 to Brett in order for them to be the same. Even though Anna has 5, so it seems like Anna plus 5, she has more than Brett already. So in order to get the same number, you got to add 5 fish to Brett. That's why it's B plus 5.
You could do like A minus 5 equals B.
You could, yep. Yep. Yeah, that's good. Another way you could do it is A minus 5 equals B. That works as well. And you see if I rearrange this, it's the same equation, right? You see how that works? All right, so that's our first equation. Now the second equation, it says they two have a total of 31 fish. So what can I do for that equation? Yeah, look it.
A plus B equals 30.
Good. A plus B equals 31. So here are my two equations, okay? I'm going to use this one and this one. Just get rid of those for now. Those are the two equations we have. All right? Now the question is, how many fish does Anna have and how many fish does Brett have? So we need to now solve for A and B. So it's the solution to the two lines, right? To the two equations. So now we're in a situation where we can solve. So what would be the first step here now? Alan. Say it again. So what's the first step in the solution to linear systems? What's the first step? What do we got to do? Go back here. Okay? First step.
Okay, so
What does it say?